In this example, we're going to solve for a phase-shifted angle. That means that we've got a plus or minus inside of our trig function with the x. What we're going to start out by doing is solving for the x minus 20. If we look at the form of this equation, because we have a cosine squared, that means that this is quadratic in form. We want to have everything on one side and a 0 on the other side, which we already have. And then what we want to do is try and factor this. In this one, because we've got a cosine squared here and a cosine here, that means we can factor out the cosine of x minus 20. What we have left when we do that, we took out one of our cosines, so we still have a cosine of x minus 20 degrees here. And then here we took out everything that was here, so we have a plus 1. Now we're going to take each factor and set it equal to 0, and keep in mind that this x minus 20 is inside of our cosine function. So this entire thing is one factor. We're going to take that and set it equal to 0. And then we're going to take this whole factor and set it equal to 0. What we want to do for right now is solve for the x minus 20 degrees. So we want to think of an angle between 0 and 360 degrees that has a cosine of 0. There are actually two of these, so that means our x minus 20 degrees could either equal 90 degrees, because cosine is 0 at 90 degrees, or it could equal 270 degrees, because cosine is also 0 there. And then for this one, we want to get our cosine function by itself on one side, so we're going to subtract 1 from each side. Now we're trying to find an angle between 0 and 360 degrees that has negative 1 for a cosine. That would be at 180 degrees. So from this one, we get x minus 20 degrees equals 180 degrees. So for our x minus 20 degrees, we've got three solutions between 0 and 360. We have 90 degrees, 180 degrees, and 270 degrees. Now that we've got the solutions for that, we can actually solve for x. This time, instead of multiplying or dividing, to solve for x, we just want to add 20 degrees. So we want to add 20 degrees to each one of these three. If we add 20 to 90, that gives us 110. If we add 20 to 180, we get 200 degrees. And if we add 20 to 270, we get 290 degrees. Those are our three solutions that we would get between 0 and 360 degrees. And then all solutions, we're going to take each one of these and add 360 times n. So we'd have 110 plus 360 degrees n, and 200 degrees plus 360 degrees n, and 290 degrees plus 360 degrees n. Now for our last example from this section, this is going to be a little bit like what you'll be doing for the project this week. We've got a sine function that has a period change, and it also has an amplitude change. And here's what the graph would look like on your calculator. What we want to know is when this value would be equal to 0.004. So really what we're trying to find is where this reaches the maximum point at each of these places. But we only want to go over the interval from 0 to 0.02. So we're going to go about halfway through this graph. So we want to find where these values are. But what we can do is just set up our equation. We want to know where y is equal to 0.004. So we're just going to replace the y on the left side with 0.004. And we're just going to solve this trig equation. The first thing, our trig function part, is all of this right here. We want to get this by itself on one side since this is a linear type equation. So we're going to divide both sides by the 0.004. That gives us a 1 on this side, and on this side we just have our sine of 300 pi x. Now this is one where we have an angle multiplier. It happens that our angle multiplier is 300 pi. So we're going to start out here by solving for 300 pi x. We want to find all solutions for this. And this is going to be in radians since we were doing the graph. For the graph, the x has to be in radians. So we want solutions in radians. Between 0 and 2 pi, where sine is equal to 1, that happens at pi over 2. 300 pi x would have to equal pi over 2. That's our only solution between 0 and 2 pi. Now we want to write down all solutions. So we're just going to take this one and add 2 pi times n. Those are all of our solutions for 300 pi x. Now if we want to actually solve for x, we're going to divide everything by 300 pi. Both of the terms here have to get divided by 300 pi. That's going to give us x. If we take pi over 2 and divide that by 300 pi and then simplify it, we end up with 1 over 600. If we take 2 pi divided by 300 pi and simplify, we get 1 over 150. So we have 1 over 600 plus 1 over 150 times n. Those are all of our solutions. So this would give us all of the points where we're getting this maximum value. Now we want to know the solutions just between 0 and 0.02. So we're going to go through and put in different numbers for n, starting with 0, and keep figuring our solutions until we get one that's bigger than 0.02, and that's where we're going to stop. So if n is 0, then we're just going to have 1 over 600. 1 over 600 is approximately 0.0017. So that's definitely in the interval that we're looking for, between 0 and 0.02. Then we're going to look at what happens when n is 1. We'd have 1 over 600 plus 1 over 150 times 1. So if we add those two together, the fractional value is 1 over 120. The approximate value for that is 0.0083. So that's still in the interval that we're looking for. So we've got two solutions so far. We're going to go up to n equals 2. That gives us 1 over 600 plus 1 over 150 times 2. The fractional value for that is going to be 3 over 200. As a decimal, that's 0.015. That's still in the interval. Now we're going to go to n equals 3. The fractional value for that is 13 over 600. If we do an approximation for that, it's 0.0217. That's bigger than the numbers we were looking for. So we're going to forget about this one. So that means that we've got 3. And we can do them either as the fractional values or as the decimal values. Fractional values, it would be 1 over 600, 1 over 120, and 3 over 200. Those would be our exact values. Approximations would be 0.0017, 0.0083, and 0.015.